So it's 5 after, so we can go ahead and get started. So my name is Matt Champlin. I am ATA for Comp15. Also on this call is Matt Russell, who is a grad TA. Is that correct? Maybe if you can hear me. I don't know exactly what your title is.
Yeah, grad TA / co-instructor. Yeah.
Yeah. All around smart dude. And Ananya is also on the call. She's also a TA. You can say hello, Ananya. Or not. Ananya doesn't want to say hello.
Hello, everyone. I waved.
Oh, you waved. I did. Yeah.
Yeah.
Sorry. I don't even have like my camera up. So yeah, let's get started. So this is VS Code for those of you who haven't seen this editor.
What editor do you guys mostly use? Can you put it in the chat or?
Cool. Anyway, this is VS Code. Some of you guys probably use Atom. It doesn't really matter, but I'm just going to show this little spot here that I'm typing in. This is my terminal, so if I do a quick ls, we can see all my folders here on Halligan. And then, I'll show you here in a second that it just opens up files still left and I'll be editing them there. But so ls, for example, is one command that we use to, there's SL, I actually accidentally typed it. So here's a train. If you type use comp40 and then you type SL, you get that nice little train graphic. But anyway, ls
does anyone remember or know what ls means?
I actually don't even know. What does it mean? List something? List? Maybe it's just list.
I more so meant what does it do?
Well, yeah, it just lists files where
it lists it lists files that are in the directory that you're in.
Yeah, or you can do like ls and you give it like a directory and it'll show you what's in that. So like there's some stuff in there. So you can give it any directory. If you do it like this, it just automatically just does it on whatever the current directory is. If you want to know what directory you're in, you can type pwd and that shows you where you're at currently. But yeah, we can get started here. This is another useful thing that command that you guys will use. I'm sure you already have a make mkdir or make dir. So I'm going to make one for this. We'll call it demo. Right. So now I've made a little folder here called demo, and we can go into that by using cd. So cd means change directory. So now we're inside a demo. And oops, now I killed my terminal. Yeah, so those are some like super basic commands, but they're going to be using them all the time. I'm sure that you're familiar with everything I've just said. But so now one way of creating files, I can do, because VS Code is cool, I can do something like this. So we can just call this test.cpp or something. And that'll bring up this file. If you use another editor, there might be other ways to do it, but you can also do something like the command touch, new file. Touch will also create a new file, so you can see it there. So that's one cool way. You can echo stuff into it. Hello. So echo normally just prints to the screen like that, but you can do a cool thing called redirection using that little caret. So we can echo hello into new file, and then now we can cat just basically prints it out. So that's kind of cool. And if you wanted to,
so Fortune asks, why would you need echo?
Oh, echo. If you just wanted to like put something into the file. So right here, when I echo hello and then redirect it using this little caret here into new file, what that's doing is it's putting the word hello into the file new file. All right. So echo basically just prints stuff to the screen, right? But so if I echo hello, it just prints it like that. But if I echo hello and then redirect that into the file, it'll put it as like the first line. So if we open up a new file, you see hello, and then I can like echo by. And if you use 2 carets, it will append. So there it is. Kind of cool. A bunch of different ways of making a file. That's, all I'm trying to show. Touch, if your editor's cool like VS Code, you can just type code. So let's get rid of.
So Fortune asks, does hello become a file or is it just a word?
So yeah, go ahead.
Oh, sorry, you go ahead.
No. So hello doesn't become a file. Hello gets put into the file that we made. So we can do this. Let's get rid of it. Let's get rid of new file. I don't know why it's getting weird looking. So now we don't have new file anymore. If I do this, and then I redirect it into something called new file. If new file doesn't exist, it will actually create it. So now we have new file here. We can cat new file and the word hello. So this is a way of actually making a file as well if you want to put something into it right away. Or you could just say touch. Yeah, it's kind of cool. So then RM is how you delete stuff. So RM is like remove new file. And if we wanted to, let's make another directory called delete me. And let's echo stuff into we can actually put this right in that new folder. So we can do, is that what I made it? Yeah, delete me, delete. So now we have a file called delete inside of a folder called delete me. Now, if we try to, like say we want to get rid of this whole directory, if we just say remove delete me, it's going to complain because we need a special flag to tell RM what to do. So if we do RM and then R I believe is recursively, is what that means. So basically it'll go through and remove everything in that folder recursively, including the folder itself. So now we're cool. Now we can delete that folder and that is gone forever. So be careful with your RM commands because there's no reversing it. Although you do have, there is a thing called snapshot. If ever you accidentally delete everything or mess something up, or you just want to go back to an old version, the Halligan server actually keeps I think every 4 hours it backs up your files automatically, and then every day it also backs up your files. So you have the previous day and every last 4 hour segment. So if anything ever were to go wrong, you can actually recover your files. But just be careful with RMs as they are pretty permanent. There's no undo, right? So all right, so let's. Does anybody have any questions over any of those commands I just showed you? Everybody's probably feeling pretty comfortable with that stuff. If not, if there's anything in particular you want to talk about, feel free to stop me. So yeah, so let's make hello world. Let's do that. Let's get rid of test. I don't like that name. And let's make hello world instead. So by convention, we use .cpp as the extension for a C++ file, which is why I call this hello world.cpp. And at the top of most of your, probably every C++ file you're going to write, you're probably going to do something like this. Put a include directive and let's add IOStream. IOStream is the thing that allows us to print to standard out or standard error. So in general, if you want to see something printed to the screen, you're going to have to use this include directive. And what this does basically is this IOStream is a library of functions and things like that that the people who wrote C++ made for us to use, right? So we don't want to write our own custom, file output stream or standard out stream. That would take forever. Oh, as long as we want. I don't have like really an end, but I'm guessing by 6 it'll probably naturally wrap up. As long as there's still questions, I mean, I'm down to stay. So, but yeah, probably about 6 is what I'm guessing. But anyway, so back to the includes. So this is like just a nice thing that C++ writers gave to us, so that we don't have to write a custom input output stream. And then for every program you write, you're going to have one function called main. So that's what we're going to do right here. So we have this main function, right? And then we want to return 0 from this. And returning 0 from main means a successful run of the program. So this is kind of, every C++ program has to have a main. And that main will go in different places depending on what your program does. But main basically is what drives the entire thing, right? So a lot of times people call their main.cpp, or they'll call it like driver or something like that. But so as it stands right now, we've included IOStream, so we have a way of printing stuff. We have a main, so the program knows where to start running. And now we can do print hello world. All right, and you may be wondering, what is this nonsense here? Well, so the reason, well, we can compile this really quick, and we're using G++ this semester, so let's do that. So now if I just give it hello world, this command here, this is telling me what compiler to use, so we're using G++. This is warnings all, and hilariously, all warnings are not all warnings, so warnings extra. When you use the warnings all, it actually doesn't include all the warnings, which is hilarious. Computer science stuff. So this is like a general command here. If I don't give this, what I could do here is use this -o and then say name it hello. Yeah, I'm going to explain that here in a second. You don't have to use that, but it's only if I use a particular thing called using namespace std. So what I wanted to show you is, just in case you run into this, you understand what you're looking at. So if I do this, if I don't give this a target to make, this should make a file called a.out. So there's a.out. We can run a.out like that. /a.out runs it. If I were to do that same compilation command, but do a -o and call it hello, now it should have made an executable called hello. So hello also runs. Yeah, so this here, this cout is part of the IOStream library, but it also, it has this, it's in the standard, oh God, what I'm butchering this. It's in the standard library. So if you don't say using namespace, you can include this, and now we can get rid of the cout, the standard. Basically, this std : is telling it to use the get it from the standard library. Use the cout function from the standard library. Now, if we include this, we don't have to type those colons anymore, so we can recompile this thing and then rerun it, and it does the same thing. So if you include this, yeah, there is a Piazza post about that as well. It's probably more eloquent than what I just explained, but that's the general idea. So if you include this at the top of your files, then you can avoid using the colons. And everybody cool so far? Any questions thus far? Awesome, cool. Yeah, thanks, Fortune. So here's where we kind of get into like a little bit of the details now about how things are a little bit different if you're coming from a Python background. So in Python, you can kind of just say, I don't know, what should we call this thing? Let's call it, no, say I want a number. Python, you just do this, right? And Python figures out that this thing is a number because of what you've put here, right? In C++, I believe that's called dynamically typed language. C++ is not a dynamically typed language, so we have to tell it exactly what these types are, and this is good and bad. This is good because you're guaranteed that this thing will never change value. Like number always has to be an integer, so anywhere you use number, it's an integer, which is kind of nice. But you always have to tell it exactly what you're making. It doesn't figure it out on its own. And so now we can also cout number. And if we recompile this bad boy, run hello, and there's our 10. So beautiful. Yeah, in C++, there are a few like built-in or basic primitive data types, integers, characters, and strings. So C++ does have strings. So if you're coming from C, where there isn't a string library built in, C++ actually does have a string library built in, which is nice. So if we made a string, this is one way of initializing a string. And we can now print out hello. Or not. That is weird. What? Oh, yeah. Semicolon. There we go. Boom, hello world. Yeah.
Did any of you take Comp 11 here, or are you guys mostly like coming from different backgrounds?
Yeah, cool. Comp 11. That's good. That's good. So all this is probably very familiar. You're probably bored. So we can get into some cooler stuff. Cool.
CS50? Okay, cool.
Yeah, did you do C++ in there, or was it some other language?
I know CS50 does lots of different languages, like a little bit of each, not
yeah?
really like the traditional.
Okay. Yeah, cool. So C and
Oh,
Python.
interesting.
Okay, yeah. Cool. So C is you'll be very comfortable if you know C at all. You'll be very comfortable in C++, as C++ is one more. That's kind of the joke, the inside joke. C++ is C incremented by one. Cool. So we talked about getting things out using cout. We've talked about integers and things like that. I guess we can do this. We can say, let's cout something. Let's say, give me a number. Give me a num. And instead of number here, let's do cn. So this is how you take parameters or data from the user, is using cn. So, and then notice how the little arrow brackets flip directions. So stuff is going from here that way, right? So then when we're going out, stuff is going from number out to the screen. So anyway, the way that your brackets face, I forget what these are called, insertion operator, I think. Well, anyway, in any case, this is how you take in the number. So we can initialize this, say, to 0. And we're going to say, give me a num. And let's give it 42. And then it prints out 42. So, yeah. So I guess, what should we talk about? Should we talk about pointers, Nanya? How you feeling?
Yeah, I think that's what most people, at least in office hours, were having trouble with.
Yeah, so let's talk about pointers then. So we have our little program here. It's a pretty basic program. So we can, in order to declare a pointer in C++, it's basically the exact same syntax as making any other type, but you just use this little star and you put it in front. So let's call this num pointer, right? So this is how we make a pointer. So we can have it point to our number that we get from the user by getting the address. So the ampersand here is a way of getting the address of any variable type. So if you put this ampersand in front of anything, like say we put it in front of the string, it would give us the address where string is being stored in memory. So right now we're going to have num pointer get the address of number. And if we print out num pointer here, this is where it gets a little bit weird, because these stars and these ampersands, they mean kind of different things in different contexts. So while we here are telling it, hey, give me a pointer to an integer, here we're saying, hey, go to that address in memory and give me the value that's stored at that address in memory. give me, well, really give me the address of this number thing and tell me what the number is there. And this is called like dereferencing, right? So this is where stuff can get a little weird. So let's compile this and run it again. Let's get 42 again. 42. So notice how we printed out number by dereferencing this pointer. Yeah. So we can have pointers to all sorts of different types. So in your like array class or array list class, if you didn't, yeah, you would just get the address, right? Exactly. So we can see the difference between that right here. So let's get 42, and now it gives us this weird long string of numbers. But this is the address in memory that num pointer is pointing to. Right. Samantha, memory, go to specific address. I guess yes, and go to specific address. Yeah, I'm not sure what you mean by your question. Are you asking if this a specific address or? Yeah, so the ampersand gives us the address of number. If we just print it like this, we just get the address. It's okay.
Yes. The ampersand is like get the address of, and then yeah, exactly. So the asterisk, the star is get what's at this address. To go to this address and get me what's there, or just access that address.
Yeah, exactly. So and so we can have pointers all kinds of different times. We could have a string pointer if we wanted to, but it was important to note that like you do have to call it what it is. We couldn't have this integer pointer point to the string. That wouldn't compile. So if we try to do num putter, that's the address of hello. This probably should yell at us and be like, no, I don't like that. That's not the right type, right? Because that's a string. So we can't point an integer pointer to a string. So these things are what they are, and they are that way until you delete them. So this is always going to be an integer pointer. You can't use it in any other way except for to point to an integer. Well, the cool thing about that is if we have a pointer to an integer, we can have basically like if we could use this as the first address of the first item in say some long array list, right? So I think it might be characters for the homework instead of integers, but when assigning a num pointer, do we have to include the address of number? No. Well, you do when you're assigning num pointer to this. You do have to use this little ampersand to get the address of number. So num pointer here, we're declaring creating a num pointer, an integer pointer here called num pointer, and then we're giving it or saying, hey, go point at this thing which is an integer, and get its address using this guy. Oops, using the ampersand. Yeah. So I feel like that, is there any other questions? Nani, do you have anything to add? Or Matt, anybody? Yeah. So let's talk about, we could do sort of like a little demonstration of passing by reference or value or that kind of thing.
Does anyone know the difference between passing by reference and passing by value? Because I know that they do go over this in 11.
Let's do pass by val.
Okay, well, I guess.
Yeah, exactly. So by default in C++, everything gets passed, when you pass something into a function, the function itself makes a copy of whatever that is that you're passing in. And so you can use it within the function itself, and it won't have an effect on the thing that you passed into it. So on the outside, in the scope of the outside of that function, that integer or whatever that thing is remains unaffected. But inside the function, you can mess around with the value of it, but it'll only stay that way for inside the function. So, and I guess this is a kind of a cool demonstration too, because now we have this pass by val here. In C++, you can either declare and immediately define the function here, but by convention, we don't do that. And that's, you want to declare all your functions up top and then define them here. So essentially, it's a lot of like copy and pasting, but that's kind of just stylistically how we do. So if we do val gets val plus 10, and then we, let's just see out val here. Can't type today. So let's get rid of all this stuff. I guess we could still get a number. And let's call pass by val on number. So what we'll end up seeing is that, and I'll make this a little bit more clear. What we should end up seeing here is that when I pass in, like I'm going to pass in 42, right? When I pass in 42, we'll see that value gets changed to 52 inside of here. Then when we come back out, we'll see that the number, oh, this should not be num pointer, it should be number. We'll see that the number itself has been unaffected by that. So this is the default state of C++. So I'm actually surprised I read 42 with this thing there. So as you can see, like inside the function, we get 52, but number itself hadn't been changed. And that's because when we pass in number or val here, C++ made a copy of that. So it became unaffected. So if we do pass by ref instead, we give it a pointer val. Now we're saying we're going to pass something by its address, right? So now we should see that if we just change this to ref instead. Now we should, oops, yeah, you know what? Let's just copy and paste this bad boy and call this pass by ref. And we'll call it pass by ref. Now we should see that the value does change, and we need to pass in the address. Or not. Yeah, but with pass by val, we're making a copy. Yeah, that's right.
Good job picking that up. That's important.
All right, what have I done wrong?
This just goes to show that like everyone gets bugs, and it's a good thing to get bugs because then you, yeah.
Let's do it. Let's bring this back. And so we can do, well, I can show it like this as well. Numputter. And it should be.
Oh, sorry, Jose. Does doing star, okay, so are you asking like the asterisk followed by an ampersand? Okay, great. So if you are dereferencing the address of something, what do you think would happen? So
I really can't type today. Yeah, so let's do plus equals 10. Yeah, like so what Anya said, like what she said. Everybody gets bugs. There we go. So finally, we got there. So that's some of the tricky stuff about like, see, I forgot to, dereference value here when I passed it in. I forgot to dereference value here when I was printing it. So I got all kinds of wacky output, right?
Okay, I'm just trying to keep up with the chat. So Jose says, if I'm not passing a pointer, does not work then. Could you clarify? You can unmute and just clarify what you mean. I think that would be easier.
Sorry about that. I'm talking about like for example, in the pass by ref, if I was trying to like my understanding is that if I use the ampersand to ref, I could just access a non-pointer variable, right? And then just modify its value.
If you use the ampersand, oh, okay, I see what you're saying.
That's correct.
Yes. I understand what you're saying. So you're saying if you use the ampersand to get the address of something and then you dereference that?
No. It's simpler than that. Yeah. So if it's not a pointer, it's fine. So
Yeah. It doesn't need to be a
the
pointer.
declaration. Yeah. It's just the
Right.
right.
I guess my question is adding, if I am passing a pointer, is adding the reference operator on the top with the ampersand just a way of not having to do it below in the function?
I'm not quite sure what you're asking.
So I've seen like if I take your pass by reference function that you have right now, I've seen some people do like int star ampersand, whatever you name that.
I see. So
Is that just so you can pass a pointer and get the value right away as opposed to having to do reference below?
No. So that's passing a pointer by reference, which is not really great practice generally. So for that, you would be able to update the value of a pointer, which is a memory address in the function. So that's like passing a pointer, and then the memory address of the pointer that the pointer contains, you can just change inside the other function. But it's not a great idea.
Gotcha. Okay.
Yeah.
Generally, this is the pass by reference standard is how it is right now.
Yeah. If you're dereferencing the address of something and you're trying to modify that, if something is stored at 0x001, for instance, I guess you could technically change it to 0x002. But that could, if you don't really understand how memory works, like if you haven't taken Comp 40 and that stuff, don't do that. Because it could mess up your program unless you really know what you're doing.
Gotcha. Thank you.
So like Matt said,
Can a pointer point to another pointer? Absolutely. Yeah, you have an array. A 2D array is a double pointer. Actually, we do use a lot of pointers to pointers.
So if you have a pointer pointing to another pointer, do you if you delete the first pointer, do you have to delete the second one, or if you delete the first one, it deletes both of them?
I see what you're saying. Do you mean when you're freeing the memory?
Yes, exactly.
Yeah. If you allocate a space for a pointer, so whenever you use the new keyword, you have to delete it.
Because we had the lab, right, and then I had 2 pointers, so I had one pointer pointing to an array on the heap, and then I had another pointer pointing to that pointer pointing to the heap.
Oh, I see what you mean. Okay, so you only need to delete something if you allocate it on the heap. So only if you use the new keyword is when you need to delete it. Otherwise, double free.
Okay, gotcha.
Jumping onto what Fortune said, I just finished watching the second lecture from Mark, and the way that he handled the expand sort of function was to create a new array on the heap, and then copies the original one in there, and he deletes the original one. My question is, shouldn't then you have to delete that as well?
Right, that was my question too.
You mean delete the new pointer, like the one that you created?
Yes.
Yeah. So that's confusing,
pointer,
right?
If you deleted the new pointer, you would completely lose access to everything. So what Mark is doing in the expand function is he's taking the original array and he's copying each element into the new array.
So
And-
that pointer itself gets destroyed at the end of the function call. But you've assigned before that, hopefully, you've assigned the pointer that's part of your class, like in the private section. You've assigned it to point to that that address in memory, right? So even though that pointer gets destroyed at the end of the function call, you've saved basically the address of that memory in your variable. Like we can actually write it because I think this goes nicely into making a class. So maybe we'll just jump into that real quick. We can do a quick array list. So let's do that. I don't want to write your homework for you, but this is yeah. But you could have since we already did this in lab, I don't feel too bad. Or actually, Matt, how do we feel about this? Should I not do an array list class? Probably not. I don't want to do your homework for you guys.
Well, I mean, part of this is done in the starter code.
Yeah.
I could try to check how much is in the starter code.
Okay.
Matt, I don't want to get you in any trouble.
Yeah.
I understand the way that class is made. I was just a little confused at the I guess you explained that sort of temporary
Yeah.
array gets then just deleted by the end of that
Right.
function. I just
Right. So like
thought that you needed to add it to the structure as well.
let's just pretend here. I'll write expand really quick because I don't feel like this is giving too much away. But so essentially what we're going to do is what I like to do is do the capacity part up front. So this is assuming that you have some variable called capacity in your class, right? So I like to do ×2 +2 because just in case you are you initialize, say in your constructor, you initialize your array list to 0. If 0 times 2 is still 0, so then the thing would never expand. So we always like to add like 1 or 2. I like 2. I don't know. I like nice even numbers. So then what we're going to do here is we're going to make a temp array, right? Pointer. So this is the part we're talking about here, where this temp array right here.
Right.
And then we make this with capacity.
I think this is pretty good. I think we could maybe stop here.
Yeah. No, exactly. But I just wanted to demonstrate that this guy right here, this gets destroyed at the end of this function call. But assuming you have some array pointer, like pretend this is your array pointer, then you would just assign that to. So this doesn't get destroyed, and now it points to wherever this has been created in memory. Yeah. So I don't want to.
Oh, gotcha. Okay, that's all I wanted to know. Like how that if that temporary one just got deleted at the end of that function, you didn't need to do it
right, but
later.
So this pointer is just like eight bytes or whatever. I
think it's four, but yeah.
Is it 4? I thought it was 8 in Halligan. Anyway, so so this points to the new memory, but this isn't the array, right? This is just a pointer to the first element, right? So
no, you're right. It's 8.
It's 8. Yeah, I think it was 8 on Halligan.
Yeah, I'm good.
But yeah, so that's how that whole thing works. So, all right, so we won't write an array list class. Let's write.
Thank you. That is my question.
The general idea too, I'll just quickly mention that when you allocate memory on the heap allocated memory is just pointed to by a pointer, and hopefully it's pointed to by a pointer. Otherwise, you just lose it. So you have to delete anything that's allocated on the heap, but pointers themselves are allocated on the stack. So you don't have to worry about. Does that make sense?
It does. I think you just cleared up some my confusion there.
So if you write like if you declare a pointer like int star num pointer inside main, and don't point it to anything on the heap, then you don't have any memory, no memory leaks.
Right.
Yeah. Cool.
Thank you very much.
Yeah, of course.
Yeah, it answered my question too.
Awesome. Great. That's good. So let's make a class. So let's make this student class. So like first steps, we do this thing, if and def. So if not defined, and then generally you want to make it some kind of something. You want to give this, I think, Matt, and correct me if I'm wrong here, you kind of want to make this something that you wouldn't use. So This is sort of a convention.
I usually would do it. You don't necessarily need the underscore below or you know at the beginning and end, but all caps student underscore H is great.
Yeah.
Yeah.
So yeah, and the idea here is like you're basically hold on, define.
Yeah.
Go ahead.
No, yeah. You got it.
So from what I understood is it always it like you want to name this something that is close to your class name that you won't use in your class, because now this name, so we can't have a variable called student underscore H, right? Is that how that works?
Yeah, the idea is that you often run into situations when you have more complicated combinations of classes where you can have multiple redefinitions of the same code and the compiler will complain.
Right.
So if like student.h is included in a bunch of different places, the compiler would complain. But if you use this if and def student H, then the compiler will only define it one time, or it will only be defined once. So if you include it multiple places, you won't run into to issues. And those kinds of errors are really hard to debug because you just get these weird, like, you know, just weird looking errors. So just using these header guards in advance is good practice and will save you a lot of time.
Right.
Is that similar to Pragma ones? The purpose of it, I guess.
Yeah, I'm not sure. I'm not super familiar with, but probably. Yeah. Similar deal. Yep.
Yeah. All right. So I've kind of started making this student class, right? So we're gonna we do the include guard stuff. So if not defined, student H define it, and then here at the end we have to put end diff, so end define, right? And anything in between becomes part of your class. And classes generally have like a public section and a private section. The private section is not accessible outside of the actual like student code itself. So you can't access anything here. I'll demonstrate that in a second because maybe that's not clear. But say we, so students have an age, right? So let's give the student an age, int age. Let's give them a name. So far we have age and name. And let's say we wanted to get that stuff. So we want to be able to see it. So let's do void, or actually let's have a return an int. Get age.
I just looked it up, by the way. It's basically the same exact thing as Pragma once. It looks like people on Stack Overflow are having a heated argument about it, which one to use. But for the course, we use. Of course they are. For the course, we use these header guards with if and def.
Perfect. Thank you.
Mm-hmm.
So now we've imagined some kind of a couple functions here, like one to get the age and one to get the name. So this is like a very basic setup of a class. And so the header file here, this .h file, is where we define everything, make all the declarations. Sorry, we don't define them here. We actually just make the declarations here. And then in the student.cpp, this is where we're going to actually define all that stuff. And so we need to include student.h. There it is. VS Code is smart enough to know that I have that. And then we can just start writing the function. So, but crucially, we have to tell it, well, first we have to give the return type, and then we have to tell it that it's in the scope of this student to like basically look in the header file. It's in this student.h header file. So how we do that is, well, first let's make a constructor. Yeah, this is correct. So let's make a student. Destructor. imagined two functions, int get age and string get name. So we first have to tell the return type. And then we have to tell it, hey, go look in the student class. Get age. And string student get name. This one didn't auto-populate. Cool. And for this, we're just going to return age. And this is just going to return name. And for our constructor, we're going to set age. Yeah, it's, I don't know, 21. Name is Sally student. Destructor doesn't have to do anything because we're not allocating any memory anywhere on the heap. So this could, we can even just write a note that says nothing to do. Generally, if you have any heap allocated memory in your class, like you guys will for your array list, then this will have to take care of getting rid of or deleting all the memory that was allocated by that instance of that class. But since we only have primitive data types, these handle their own memory for us, which is nice. So we don't have to do anything. But this is 2 out of the big 3 here already. So constructor, destructor. Cool. So now if we want to use this class, we can go back to our hello world code here. And let's, the way we use this class now is we have to include it. So here we do another pound include, and we say student.h. So now we can create students. We can make all the students we want. And basically just to make a student, we say student stu, and this will call the default constructor, which is any constructor that has no parameters is the default constructor, and that is the syntax here, right? You can have all sorts of parameterized constructors, which are pretty cool. So if you want to be able to make custom students, we could have another one that has, say, name and age here or whatever, and we can set variables automatically by doing that. But for now, we've hard-coded that this student is going to be called Sally student, and she is going to have 21 years of age, right? So
yeah, the way that the program, I guess, knows which one to use is based on the parameters you give it. So in this was something that I used to be confused about back when I first was learning how to code, but that's how it, so if you do in the main function, if you do student, if you do student, and then you give it 2 parameters or whatever the number was, it knows to use the parameterized constructor. So yeah. What's the purpose of constructors with parameters? Why would we want to use it? Great question. Let's say, so right now let's use this example. We have student class and we initialized it, we hard coded it. So we said age equals 21, right? But like, that's not practical. Not every student is 21, obviously.
Yeah.
And so if we have the parameterized constructor where we can pass in the age and pass in like the name, for instance, we can customize it a lot more. So it allows the user or like the client to put in whatever they want and create an object with whatever they want. And it doesn't have to be hard coded.
Right, exactly. I can make a make a demonstration of that in a second. Yeah, I think that'd be helpful. So I was kind of coding while Ananya was explaining that, but so now this is how we like create an instance using our default constructor here. So we have a student object, and now we're just going to use those 2 functions that we just wrote to get the name and the age of the student. And basically, so what I want to demonstrate here is that I can't just grab those 2. I needed to write these 2 getter functions to return the values that we set here for these 2 guys, right? And those have to be public. So anything that I put in my public part of my class here, I can call from here. So since those 2 functions are public, and hopefully this compiles, we're gonna need, I can call those now from here. But crucially, I can't directly access age or name. So if I try to do something like this, stu.name or something, it's going to complain. It's going to say that's a private variable. You don't have access to that. Right. Oops. Hello world. Get a string a name. Ooh, I have defined things wrong somehow.
Oh, you just need to include
IOStream.
string. Oh, wait, hold on. String does not name a type.
Yeah.
String get name. No, string.
Just string.
String. Yep.
Interesting.
And
I thought that
then
was
and
built in
then
IOStream.
and then you either need to use using namespace std or std : string.
Yes, you're right. So let's just
And-
do using namespace.
Yeah. Mark has mentioned that we definitely don't want to do it in the .h files, and you're probably still going to get an error there. So you in student.h you can do std :
Gotcha. Okay, so we don't. Okay, so that is the new convention.
Yeah, I mean, it's such a pain to like remember all that stuff. I just do std : because it
Yeah,
looks
right.
kind of annoying, but generally it's easier. So also you want it on line 12.
Oh, sorry. Yeah, you are right. Thank you, sir.
Mhm.
This whole live coding thing, it's always fun.
Oh yeah,
Okay, there we go.
Always little issues.
Yeah, like how much do you actually remember of all of this?
Yeah.
So cool. So now we've made a thing called student test, so we can run student test now. I was close. I almost had it all the way right.
Mhm.
So there we go. So now we're printing out Sally student. I forgot the space in front of age, so it looks a little wonky, but essentially we have gotten this thing to work. Training student 24 and what? That's weird. Why did it compile last time? Do I have to type here too? That's funny. There we go. Oh, funny enough, it didn't complain the first time, but we got there. So here we go. So, but yeah, so like I was saying, you can't access these directly. These variables that are in the private section here, you have to access them through either some kind of getter or some other. That's the only way you can. Yeah. So okay. So back to what I'm talking about, parameterized constructors. So let's imagine that we want to set the name and the age of the student by some other way. We don't want to hard code it. So maybe our default is going to be Sally student 21, but we want to be able to make all sorts of students with all kinds of different names and ages, right? So let's do name. And let's give it age. So we can imagine another constructor like this. Let's put that guy right here. Oops. And then say name. Actually, don't want to say name. What's another name for name? Let's call me this. It's old. Okay. So name gets call me this. Age gets this old. Got to change that over here as well. Call me this and this old. So now we can have some fun and get the input from the user, say. So let's make a string name say. Now we can call, so now we're going to take name and age from the user, and now we can pass name and age here. And we should. Myself here. There we go. It works. So we've made a custom student with my name and my age. And yeah, so that's classes in a nutshell. What is the purpose of construction? Yeah. That's how and why we'd use it. And somebody wants to talk about makefiles in the unit test. So Matt, I'm happy you're here. I think there's, I think maybe there was some confusion with like where's main in
Right.
in that. I had a couple questions like that in lab, so maybe you want to.
Yeah, I can go over that. Sure.
Yeah.
Should I share my screen?
Yeah,
Okay.
I can be done.
Cool. So let's see. Okay. All right. I guess I should, let's see.
Does anyone have any questions? If you do, put them in the chat and I'll get to them.
Okay, so make file and unit test. We can totally look at this. Oh, did it work? It worked. How about that?
Yeah, we
Okay,
can definitely
so-
finish.
So I'm in the homework server now, and we can try to make this as quick as possible. I don't need any of this. So I'll go to homework 1 and this is a starter code, right? It worked. I'm impressed. Okay. Matt showed me how to do that not long ago. This code command is pretty cool.
Pretty sweet.
Anyway, so basically, the way makefiles work, this is kind of a heavy makefile. So why don't we just make a new one? Let's just start a new one. How about we do? Oh God, sorry. Okay, we'll. Sorry. Okay. We're. Okay, and we've got something like this. All right. I guess. And what do we do? Something like that. Oops. And why don't we over here? We'll. Okay. Right. And then we do. Okay. And then. Right. And then we do. Something like that. Except this is wrong. Name, age, name, age. Okay, so, and then we'll the destructor does nothing. Great. So we've got our class, right? And what we can do is create a makefile for it. So usually in a makefile, the first thing that you see at the top is something like CXX. And oh, touch makes a file, Delia.
Yep.
Yeah, touch just makes a file. And code is this Visual Studio Code specific thing. So that's just what I'm using. If you're on Atom, you'll have something else. Just making files, that's all. So makefiles, one of the reasons they're so awkward is because they are more like Bash style language than C. And they're basically scripts that are getting run to be executed when you run the make command. So when you run the make command, it's going to look for a makefile. And it's got, look, no targets, stop. Okay, great. So we know at least that the make command will work, but it won't work unless we put what are called targets in the makefile. So how do we do this? So first, right, again, you see some variables at the top. So let's see. In our case, where did the Zoom thing go? Can you all hear me still?
Yep.
Okay, cool. So in our case, for this course, we're using Clang++. And so this is CXX is just the C++ compiler. And if you're used to C, it would be something like this. But we're doing C++. And then you usually have C flags, which is going to be the list of flags that are used. And actually, we're not using, we're just going to use the 14 by default now, I think. But we're going to do wall and extra, which is just all the warnings. So these are just variables that are being defined here at the top of the makefile. And I believe you need to not have spaces here, but I don't remember. So you might be able to have them there, maybe not. One of the things that makefiles are really picky about is spacing. And we'll get into that in a moment. So again, these are variables you can use, but this question here down here was no targets. So what is a target? The way that makefiles are organized, they are done as follows. You have the syntax is like this. There's target, and then dependencies. And then down here, you've got your command. So this is the basic syntax of a makefile. This is what it's going to look like. And so for a target, we're just going to say, I don't know, student. So this is going to be the command when we run make, we'll say make student. Okay. And if I do that now, something will happen, but no rule to make target dependencies needed by student. So what is, in other words, what is this dependencies thing? So dependencies are literally just the files that you need in order to run this make command. So in our case, we have student.h and student.cpp. And this is really more for you than anybody else, except when things get more complicated, what can happen is you can put something here which is actually also a target. So if there was a thing over here, I don't know, if there was another target named test, you could put test here, and then make would, after finding student, it's going to say, okay, what's all this stuff? And it's going to go to test, and then it's going to say, okay, what's in test? What does test need? And if test needs blah, 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 then it's going to go try to find these things. So it'll work with multiple things stacked on top of each other. So that's the idea. Our example is relatively simple. So it's just files here, student.h and student.cpp. And then here, we're just going to do our command. So in this case, this is syntax, right? Basically CXX and then C flags. You'll see slightly different variations of this, but in Bash, this is how you access a variable. And I'm pretty sure the parentheses are just bounding that variable to be the specified thing here. So this is basically just going to copy paste or whatever, Clang++ down here. And then these flags are going to go next. So now actually, if I do make student, see, it's actually running this command, Clang++ WAL W extra, but there's nothing after it, right? So in this case, we're going to try to make student.cpp. This is clearly going to fail because we don't have main. So, right, so undefined reference to main, okay? So we could either add the main into student.cpp, or we could put it in a separate file. I guess because we're doing a make file, I can probably just run code.
Yeah, I was gonna say.
Yeah, okay, cool. That's like literally the first time I've used that.
Oh, nice.
Okay, so here we're gonna include student.h, and then I guess stream. Okay, and then main return 0. Okay. So for now, okay, and then we'll just do Matt 95, 98. It could be 98, or the other Matt. You could be 98. Okay, so remember this constructor. We don't actually have a default constructor here. We just have the 2-parameter constructor. So this is going to be that. And then in our make file, what we'll do is we now need main.cpp, and then we're going to compile main.cpp here. Okay, so now make student. Great. So this now compiles, and it produces a.out. If you wanted to change that, you could do -o something. And now when I run make student, this is now going to produce an executable something. Notice these are in green. That's because if you look at the permissions here, this is now executable. So, okay, hello world. And then we also have our student there, but that's no big deal. So let's make this slightly more complex and assume that we wanted to do a little bit of separate compilation here. So this is going to be the executable. We're going to compile the student separately. And this is going to be, it's going to create a student.o file. And what this is going to do, oh, also the key thing here, when I was saying it's spacing, this has to be a tab. In makefiles, these need to be tabs, otherwise it's going to complain. So this one is going to do a -c, and it's going to produce student.o. Now student.o is this intermediate, what's called an object file. And then this is going to, why don't we have, and this will rely on main.o, and it's going to link them together. Okay. And then here we're going to have main.o is going to need main.cpp, and okay, and then what we can also do is just create a default rule, so we don't have to run, oops. Oh, right. Oh no, this should go here. What's wrong? Let's see, what do we got? -c, oh, right, of course. Oh, what did I do wrong here? On specifying what? Huh. Any idea, guys, TAs, what I'm doing wrong here?
Is it the -o when you're trying to make the O file?
You mean, in other words, should it just make?
Yeah, I think it
by default.
Yeah, I think it'll make the O's.
Yeah.
Oh, no! I just don't need main.cpp.
Oh, well, that'll do it.
That'll do it.
Yeah. It probably will do it by default, but just to
Yeah.
be clear. So this means compile student.cpp and output student.o. And when it's compiling, it's turning it into an object file. This is compiling main.cpp and outputting main.o. And then this is what's called the linking step, where you take two object files and you link them together. And the details of that are outside the scope of the course. Compilers is really maybe where you're going to get into the details of what is compilation versus linking. But basically, you can create a one-line makefile, but if you have multiple files around, like let's say you have 18 different classes or something, compiling them each individually is useful, because if you change something in, say, main, but don't change something in student, then when you recompile, so in fact, if we go to main and we take this out, then when we recompile, we've only had to recompile main rather than recompile main or main.cpp rather than main.cpp and student.cpp. So the more files you have, the more it becomes easier to do this type of compilation. We'll be providing with makefiles for quite a bit, but this is at least a decent starting point. Okay. Let's see. Anyone have questions on makefiles? I know that was sort of a whirlwind introduction.
Yeah.
So if there's, is there a way to force them to compile all if you have it set up like that? Yeah, so default actually makes, you mean, what you would do is just remove star.o. And typically you'd have a rule here called clean, which would just remove star.o, and then you can do make clean. And of course there are no .os there. And then you can make again. And so that will just delete all the .o files. And that's actually a great question, because when you make exec, it's going to look for main.o and student.o. If it doesn't find them, so these files exist here right now. So if it finds them there, it will use them. If it doesn't find them, it will go to these rules and try to build them, right? So that's it's just the key thing to remember about makefiles is that you have your target, you have your dependencies, and then you have your command. And that basically, if your dependency is not found inside the current working directory, it's going to look for a rule or a target to make everything, or to make the dependency. And it will go all the way down. If you've got 100 different, like a big chain of dependencies, it will figure it all out. Cool. Other questions on makefiles or compilation?
Dahlia is asking what happens when we link them. So that linking stage.
Right. So, so when you're creating, gosh, do we want to get into these details right now? It's,
yeah,
6:15.
it is sort of outside of the scope of Comp 15, but I think probably knowing a little bit about that's like this, the way the compilation works isn't bad.
Right. So, gosh. Well, do you want to take the question then?
Basically, so so there's a few steps in compilation, and the last step being the linking step, which is where it's going to take these .o files and basically try to put them all together into one executable. So the way that Matt structured this is that we're making a main.o, a student.o, and then the last step in compilation, it's going to take those two O files and turn it into one executable, which I think is called a.out now still, or is it called exec now?
A.out.
A.out right now.
Yeah.
So that a.out is the step after the linking of the O files. And that's like the most basic way to explain it.
Right. Yeah, that's an excellent high level explanation.
Yeah, thank you.
Yeah, I mean, I don't even know how to start broaching the topic.
Yeah, it's in depth for sure. But yeah, for our purposes, I think it's enough to just know that the linking step happens last, and it's really just trying to make an executable. And then somebody had asked if we could go back to the pass by reference and values stuff. So.
Oh yeah, I can do a little bit about that.
Yeah, go for it.
So right, let's look at these files. Okay, so are we clear on the fact that who's asking about this?
It was back a while in chat. Someone's like, "Hey, can we get back to
Okay.
Yeah.
Oh, Dahlia, right.
Yeah.
And you're still here? Yeah, okay, cool. Just want to make sure. So let's consider, let's take away the class stuff. Let's just focus on a function. So let's close these, close this, and let's just deal with where we are here. So I guess, do you mind if I define them up here? Is that okay?
Oh yeah. I mean, yeah.
Okay.
Don't do this.
Are
Don't
we
do
not-
this in your homework assignments that you turn in.
Oh, okay. All right, then maybe I won't.
So you gotta lead by example.
Yeah, I just don't. I haven't really heard about. Anyway. Okay. 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 So this function, pass by val, passes x by value. And oh, good, Jose. Cool.
Yep. See you.
And pass by ref passes by reference. Okay. So maybe the easiest thing to do is this. Okay, and we'll do that. So at this first function call, z, which is a variable, it's probably useful to make a quick, I was doing this the other day, like a kind of memory diagram illustrating what's going on here. And we can do something like this and something like that. So this is just an example of some integer, which we'll call it z here. So when z is declared, and perhaps it's best to do it like this, okay? When z is declared, there's some amount of memory allocated, in this case on the stack, which is whatever it is, 4 bytes or 8 bytes or whatever, a few bytes for the integer. And right now there's no value in it. And what we could say z equals 10. Great. So then the value 10 goes into z. All right, awesome. And what happens when we do a pass by value of z is that a new stack frame is created. So we'll do something like this. And this new stack frame contains inside of it an integer. And actually, well, you can almost imagine it like this, where you allocate memory for an integer. And in this case, it's called x. And we have the value 10. Okay. So we make what's called a deep copy of the information here. And it goes here. And this stack frame represents the stack allocated memory that's accessible within this function. Okay. So in other words, if we say, I don't know, x plus equals 10, like Matt did in his earlier example, then basically this would go to 20, blah, blah, blah. Okay. And that's it. It's just pretty straightforward. Now, pass by reference is a totally different beast. And pass by reference, what happens there is that when you do a pass by reference here of z, what's going to happen, it's hard to sort of illustrate it in this diagram, but you could imagine that you've got something named x, which this is going to get a little clunky. Which actually refers to this memory space. So it's very much like a pointer. However, you can use x like a normal integer. So you don't have to do the star and ampersand in terms of referencing or dereferencing pointer values. Instead, you can just simply use x like a normal integer, right? So if you say x plus equals 10, what's going to happen is this value 10 is going to get updated to 20. Okay. So normally inside the stack frame, you can only access variables that are declared within it or heap allocated memory. But effectively, this reference variable allows you to extend the scope of this into this function. Okay. And lastly, if you were to do the pointer where you do pass by pointer address of z, and then we had something here that was passed by pointer, which was a pointer to x, and then you did this. This accomplishes the same exact situation over here, kind of. So here what happens is that inside this stack frame, you have a x, and x is a pointer. So let's say that z lives at address, I don't know, oxf, something like this, right? Some heinous address. This just happens to be the memory address that it lives at. Then x is going to actually be 8 bytes allocated within this stack frame, and the value of x, so this is going to be very similar to the other example. Okay. So we now have a variable named x whose value is this memory address that's here. So when we say star x in this example, this says go to this memory address, which is here, and find the value that lives there, which is 20, and then increment that by 10. So this is going to go up by 10. Does that make sense? So these are 3 different, this is the same in practice. These 2 things accomplish in this example the sort of same goal, but they do it in slightly different ways. When you do the reference variable, you're not creating new memory, and new is a dangerous word here. You're not allocating any memory on the stack for this variable x. You are simply allowing x to refer to memory that already exists, which in this case was the memory allocated here. Okay. Whereas here, with this pointer, you do allocate the computer on the stack allocates for you space for an integer, which holds a memory address. And in this case, that memory address happens to be whatever was passed in, which is the address of z. But in terms of how they function as you manipulate them, they do the same thing where they both affect z, whereas pass by value makes a deep copy of this x such that when you do this, nothing changes. Okay, so that's that. I guess I was willing to spend time on that, but not the compilation linking.
No, that was great. That was a great explanation. Yeah, you're welcome, Dahlia. All right, cool. We'll see you around.
All right.
Thanks for coming.
Nice.
And it looks like, and then there were 3.